Today, I'm going to walk you through how to use Arduino sensor code and simulate your projects in Proteus. I promise, by the end of this, you'll be ready to impress your students, and maybe even yourself. Let's start with Arduino sensors. Now, sensors are the magic behind interactive projects. Think temperature sensors, motion detectors, light sensors, you name it. The first step is always understanding your sensor's output. Is it analog or digital? For this walkthrough, let's use a simple analog temperature sensor, the trusty LM35. I connect the LM35's VCC to Arduino's 5V, ground to ground, and the output pin to A0. Next comes the code. Open up the Arduino IDE and start with the basics. Int sensor pin =A0, void setup. Serial dot begin 9600, void loop. Int reading =analog red sensor pin. Float voltage reading 100, serial println temperature C, delay 1000. What's happening here? I'm reading the sensor value, converting it to voltage and then to Celsius. The results pop up in the serial monitor every second. But maybe you don't have all the hardware handy. That's where Proteus comes in. Proteus lets you simulate both the Arduino and the sensor before you even touch a breadboard. First, download the Arduino library for Proteus and import your Arduino model. Drop in the LM35, wire it just like the real thing, and upload your compiled code, the hex file, from the Arduino IDE. Now press play in Proteus. You'll see the simulated temperature readings just like you would with the real hardware. Want to test different temperatures? Just tweak the LM35 input in the simulation, perfect for classroom demos or debugging student projects before anyone fries a component. Here's why this matters for your students. Simulation builds confidence. They can experiment, make mistakes, and iterate, without fear of hardware mishaps. Plus, it saves you time and resources. So, to recap, wire up your sensor, write clear Arduino code, and use Proteus to simulate before you build. Bring this process into your lessons and watch your students' curiosity and their skills take off. If you found this useful, hit subscribe for more step-by-step STEM guides. Got ideas or questions? Drop them in the comments. Thanks for watching and happy making.